Total outcomes is on bottom. What's on top? Well, good thing the state assessment's not tomorrow.
What you want.
Because this is only about a fifth of what's covered. The what?
What you want.
The number you want, the desired outcome. So the desired outcomes over the total. Desired outcomes are the numbers or the item or the amount or whatever it is that we're working with that you want out of what would be the total. So let's look at example 1, top of the page. I don't have a lesson created for this, so we'll just have to go off of the book, so you'll need your book open on that. A fair coin is tossed 3 times. A fair coin is tossed 3 times. Comes up heads every time. What is the probability on the next toss that will come up a heads? Before we actually try to answer this question, what is the probability of getting a heads on a coin when you flip it? 50-50, but what is it as a fraction? 1/2. 1 heads. Probability is getting 1 head over 2 outcomes. There's a heads and a tail. Now this question is trying to be tricky, so you need to be aware of that. It says that if you got 3 heads in a row, right? What would the probability be of getting a heads on the next flip? The next flip, or the next time we tossed it, is an individual event, isn't it? We're not flipping 4 coins at one time. We're just taking a coin and flipped it, got a head, flipped it, got a head, flipped it, got a head, and then now we're ready to flip it again. If we're flipping a coin a 4th time, does it matter what's happened before or after? No, the probability of that being a heads is still 1/2. Okay. It's an individual event. If I was combining events, as we talked about in test prep, when we combine events, we have to remember 2 things from probability. Probability is the desired outcomes over the total. That was one of the 2 things. And Heidi?
Something with adding and multiplying.
Just say the second part of that. Multiply. So if we were combining events, then we multiply. But this is talking about an individual event. Okay. Example 2. 6 green marbles and 8 red marbles are placed in an urn. 1 marble is drawn, then dropped back in the urn. And a second marble is drawn and placed back in the urn. Both marbles were red. If another marble is drawn, what is the probability it will be red? Is it asking what's the combination of all these things, or is it talking about the next event? Okay, so we need to focus on that one event. What would the probability be of getting a red when you stick your hand down in an urn and pull one out? How many total outcomes are there first of all?
14.
There's 6 and 8.
Yeah.
So your total outcomes is 14. How many of them are red, Morgan? Example 2.
8.
You will work. Since the other Morgan that I was looking at is not finding the information. There, you find it? Okay. So 8 over 14, and then we reduce that to 4 sevens. So your probability of getting a red on the next one, whether it's your first time or not, is 4 out of 7. Now what is the relevance, and again, you know this, you've heard this anyway. What is the relevance or the importance of them saying that we're putting it back in the bag? If after we're putting it back in the urn when we draw it out. Heidi, go ahead.
Then, like, it doesn't change like the outcomes.
Right. The outcome will be the same, or the total number of outcomes is the same. The probability is the same every time we draw it if we take an item and put it back in. If they had kept it out, that would change our answer. And we will get to that here. I don't know if that's today or if we expand on that later. All right, example 3. A single die is rolled 3 times. The results are 1, 4, and a 2 in that order, or 3 in that order. What is the probability that the next roll will produce a number greater than 2? Are we talking about a single event or combined multiple events? Single event. Okay, so how many outcomes are there on a die?
6. No.
We're just rolling one die.
6.
So there's 6 outcomes. And how many values are greater than that, greater than 2, Kelsey?
4.
4, and so the probability reduces to 2/3.
And that's it, right?
Excuse me?
And that's it?
That's it. Now, example 4 has a combined event because we're rolling 2 separate dice. 2 dice are rolled. What's the probability that the sum of the numbers rolled is a 7? Remember what it's called when we write out all the possible results? Good. Cool. It's a sample space. They've created the sample space for you at the bottom of that page. They're showing you all the possible outcomes. Olivia, how many different ways can you roll a 7 based on that sample space? In your book. That's why I'm telling you it's there so you can look it up. That's right, go ahead and count. Look at the 7s. 1, 2, 6. We can get a 7 6 different ways. How many total outcomes are there when you roll 2 dice? 6 times 6 is 36. So you have 6 ways you can get it out of 36. That would reduce to 1/6. That's the highest. Getting a 7 is the highest probability when rolling 2 dice. And that's why rolling a 7 in the game of craps, that's the dice game with the long board in it. When you gamble, that type of stuff. 7, I think, I've not ever played. I've watched it a few times. But getting a 7, you lose money. Okay? You want to not get a 7. And I think you get to keep rolling until you get a 7. Because the odds are that you're going to roll a 7 more often than you roll anything else. And so the casino wants to have the odds on its side, or the probability on its side. Oops, that's just A. What was B? B says a number greater than 8. How many, Lauren, different numbers have a value greater than 8? 10. So on B we have 10 out of 36, and that reduces to 5 out of 18. Yes, ma'am.
Will we ever have to draw a sample space?
The only thing I would, if I'm you and I want the sample space, I would get it in my notes. Otherwise, you might have to because
Why don't you just go back to the set?
because on your
During
test
the test.
you don't get to use your book on test.
Is it be on a test?
Huh?
Is it gonna be on a test or?
Yeah.
If it's not something you want to write down now and you want to wait till it's test time and you can create it in a little minute, just go on, okay, how many different combinations, then just do that. Or just think, all right, how many ways can I get 7? One dice could be a 1, 2, 2. And you do it however you want, but to answer your question, I'd probably transfer it into my notes if I wanted to have that available to me on a test sometime. All right, designated order, and this is more of the combining events type of thing. Let's just go to example 5 at the bottom of page 286. All right, a fair coin is tossed 4 times. What's the probability? So, probability of getting the first 2 times the heads and the last 2 times the tail. So now this is combined. What's the probability of getting a heads, then a heads, then a tail, then a tail? And to get that combined probability, we're taking the probability of each event and then we will multiply. So what's the probability of getting a heads? 1/2. Probability of getting a heads? 1/2. Probability of getting a tail? 1/2. Probability of getting a tail? 1/2. And that would be 1/16. So if you're rolling you're flipping 4 coins, you could expect to get this order 1 out of every 16 times you're flipping those coins. The spinner is shown and spun twice. What's the probability the spinner stops on a 4 and then a 3? So probability of getting a 4, then a 3. Probability of getting a 4 class is 1/4. Probability of getting a 3, and that is also then 1/16.
I got a question.
Go ahead, Gus.
When you're counting on the little graph deal, do you count all the points? I'm already on
You don't count the 4 on the dice itself. You count the sum of them.
So there's
So-
only 3.
Each dice could be
It's out of 2 dice.
right. So you got a 3 and a 1 and a 3, and a 2 and a 2. So yeah, 3 out of whatever.
36.
Okay. So your assignments, what are we going to do here? 1 through man, oh man, oh man, oh man, oh man. And we need to do 28 also. I'm going to bring up a topic. If you want to keep working, you do not have to participate with this topic. But it's something I'm interested in asking. Oh, what did I put this in? In asking you guys about. And I know I am hypersensitive to cussing, language, using inappropriate words, whatever you want to call it. But it seems to me that I'm hearing a whole lot of things, or think I'm hearing a whole lot of cuss words from people in passing through the halls, in classes even, meaning kids are getting more daring with it when I'm within, and I'm not talking about you guys. I haven't heard that out of you, I don't think, mostly, maybe once, somebody. But cussing's been around a long time, don't get me wrong, I understand that. And some of your families, that may be appropriate at home, and may not be for most, I don't know the situation. But it seems like it's becoming more out there in your face. And am I off my rocker, or am I correct?
You did right. You're the
We're becoming more brave in our, not we, but as a group, becoming more brave in our talking about or saying, using inappropriate stuff. That's what I thought. Because I haven't in the 9 previous years ever heard and even given strikes for the amount of stuff that I've heard this year. You guys aren't in trouble for that. I just wondered if I was seeing that or hearing that correctly. Because sometimes I let it go when it goes by the hall thinking, well, maybe I heard something that I didn't hear, and I don't want to jump on every little person for something that I think I'm hearing. But yet, it's inappropriate, and everybody agrees with that, whether you like it or not. You understand that socially it's unacceptable. And this Oh, and we have that conversation on video if you want to.